All right, so let's go ahead and do part C. This is FRQ 2019, number 5. We're doing part A only. Since it's a number 5, that means there's no calculator being used for these questions. These are integrals that we need to do by hand. All right, let's begin. So they give us, they say R is the region enclosed by the graph of this guy and this guy. Now you want to know which one is which. I'll color code these. G is a trig function, as you can see. So it has like a wavy look to it. Notice how it's going down and back up again. Whereas H is a function that's just a parabola, so it shouldn't be going back up again. So we could tell from the graph that H is the one on top and G is the one on bottom. And we want to be integrating from x equals 0 up to here, which is x equals 2, to find that area. So the way that we find areas we talked about in class is you do your left x value and your right x value here. Then you do your top function minus your bottom function. So my top function is this guy. And my bottom function is this guy. All right, well, there's a lot going on here. If we wanted to integrate this by hand, there's a few different ways we could go about doing this. You could integrate this piece, and then these pieces separately. But I'm thinking that what might actually be easiest is to go ahead and simplify all this first a little bit. So the first thing I'm going to do is I'm going to distribute this negative in here. So that's going to become a plus 2 minus 3 cosine of pi over 2x. And for this piece over here, I'm going to expand this out. X minus 1 squared, that means we have x minus 1 times x minus 1. You could multiply it out with a box method or whatever you want, but it comes out to be this if you do that. So we're going to have 6 minus 2, and that whole thing there becomes x squared minus 2x plus 1. Now, I could have left it like this and went with a u sub approach on that piece alone, and that's another way of doing it, but I just think it'll be easier if we expand it. Sometimes it is. All right, next I'm going to go ahead and distribute this negative 2 in here. So all I'm doing is simplifying it, trying to get it look a little bit less nightmarish. Once again, it'd be awfully nice if this was a calculator question and we didn't have to do it, but this is a real FRQ from the past, and they actually expected students to do this by hand, so we need to be able to expose ourselves to these types of problems. All right, we're almost there. We could still simplify a little bit. As you guys can see, I've got a 6, a negative 2, and a positive 2. I could put all those together. Those are all just constants there. So we have, I'm going to put the negative 2x squared in the front. I'm going to bring the 4x next. And the 6, negative 2, and positive 2 all together just makes 6. Okay. So I think that's as simple as we're going to get it. Now what I'm going to do is I'm going to have to do that trig one separately because that trig one's going to require some u substitution. But the rest of it we can integrate like normal. Clean all this fun stuff up real quick. Okay, so we can integrate this. That would give me negative 2x to the third over 3. We can integrate this. That would give me 2x squared. And we can integrate this. That would give me plus 6x. So I'm going to put all that in a bracket. And once again, we're going from 0 to 2. But what I haven't taken care of yet is this part here. We still need to integrate this. Okay? So how do we do that? Well, to integrate this, we're going to have to do some kind of a u substitution. So it's going to be u equals pi over 2 x. Take our derivative, which is just pi over 2. And I'm going to multiply both sides by dx first. And then I'm going to multiply both sides by the reciprocal of pi over 2 to get my dx by itself. All right. Got to make some space again here. So this first part is going to stay the same for now. I'm not doing anything with that yet. We'll get to that later. I want to finish my integration. All right, so if I do my integration, I'm going to take that 3 out of the integral. I'm going to replace the pi over 2 with u, and I'm going to replace the, it's supposed to be a dx here, I'm going to replace the dx with 2 over pi du. We can also take this 2 over pi du out and multiply it by the 3. So that's going to give me the following. We do need to change our limits as well. I just realized that. When you do u substitution, you got to change these values by plugging them in. So if you plug 0 in, 0 times pi over 2 is just going to be 0. And if you plug in 2, the 2's cancel and you're just left with pi. So I need to change this to pi now. So don't forget, when you do u substitution with a definite integral, you need to change your limits also. Okay, so the integral of cosine is sine. All right, now we're ready to start plugging some numbers in here. So if I plug in 2 here, that's going to be 2 to the 3rd power is 8 times negative 2, which is 16. So negative 16 over 3 plus, plugging 2 in there, I get 8. Plugging 2 in here, I get 12. Minus, and then we would plug in 0. But all of those are just going to become 0 if I plug in 0, so there's not much to do there. Minus, we've got to plug in our pi and our 0. Now, interestingly, both of these equal 0, so this whole thing just goes away because 0 minus 0 is 0, and 0 times 6 over pi is that. And we can actually just stop here and call that our answer. You don't need to get a common denominator. Once again, FRQ, stop while you're ahead. There's your answer. Okay. Matter of fact, even if you didn't decide to cross off this sine part, you could have just circled this whole thing and said that's your answer. That's fine too. Once you get past the plugging in, the rest of it's just basic math, and they don't care about that on FRQs. But just so you know, this whole thing does equal 0, and this is 0. So really the answer is just this. But there you go. So that's how you do them by hand. Kind of tough. The first thing we did was we set it up. That would probably be worth 1 point, just getting your setup correct. After that, working it out would probably be worth about 2 points or 1 point, depending on what they wanted to give for that. But there you guys go. Let's move on to a different one.